Well, my name is Antonio Padovano. I came from the University of Calabria in southern Italy. And today I would like to discuss with you some topics related to education and training solutions for disasters and emergencies management in industrial plants. It's something very related actually to also supply chain resilience, because I would like to show you how these kind of solutions can be linked to the Professor Bode's cowboy theory. So here's the outline of my presentation. I would like to show you which are the motivation of my study, of our study, and to follow together from the traditional methodologies for industry, for industrial disasters training, and to go towards an Industry 4.0 driven solutions in case of training in these cases. To this end, I would like to show you also how serious games can be applied in this case, and what we intend in terms of next generation of industrial disasters response training solutions. And of course, a case study from one of our research projects. So actually, the motivation came up from the everyday bad news that we receive, for example, from the television. And there was, for a few months ago, a big explosion that has rocked in one of Italy's oil refineries in northern Italy. But actually, in the last century, there were more or less, if I remember well, 1,500 major industrial accidents. So we're not talking about minor industrial accidents that have occurred worldwide. So with hundreds, maybe, of deaths and serious environmental impacts. So that's why today I would like to explore with you which are the modern technologies in this area. And the number of major industrial accidents is actually increasing. In the last century, there was an exponential increase. Even if in the past 5 years, there was a decrease in number, maybe we assume that this was because of an increased automation. But you know that increased automation does not mean 100% reliability of the systems. And this is also, the situation is also embittered by human performances, human reliability, and human factors. So since living with the risk in industry seems to be unavoidable, how can companies and organizations guarantee the maximum effectiveness of their industrial response training approaches, and how they can enhance their preparedness in case of crisis? So you probably know at the entrance of every building on the walls there are the usual workplace emergency plans, but raise your hand if you have looked at it, maybe entering in this building or somewhere else. I think no one. Oh, okay, one. So I think there is a very little knowledge or no knowledge in some cases about which are the emergency procedures in a specific workplace. So the problem is that most of the times people used to blame the presence sometimes of emergency procedures, while they should blame their lack of awareness, their lack of knowledge. And usually in industry, there are different kinds of traditional methodologies for training. For example, discussion sessions, evacuation drills, functional drills, tabletop exercises, or full-scale exercises. But there is a major problem in these cases. These procedures, these methodologies test procedures, but not people. And this is quite a huge problem, because during the building collapse in 2013 in Bangladesh, there were mangled bodies under the rubble, and rescue was also needed for non-professional rescuers. So people went there to help other people, but rescue was needed also for them. So that's why actually the most effective solution could be full-scale exercises. But there are some limitations that you can see here. For example, we have some big efforts in the long scenario preparation. So we also need we have some prefixed storyboards that cannot evolve dynamically because the scenario has been prepared a priori. Then, of course, we cannot recreate the physical system. For example, in the case of industrial emergency management, you can imagine a fire or explosion in an industrial facility cannot be recreated in reality. So Usually, there are people telling somebody else how to behave in this case. But this is theoretical knowledge, not practical knowledge. There are also problems related to the business continuity, because people should be there working and producing something instead of training. And there are also additional costs in preparing the scenario. So what we would like to do in this case is to see the problem is not the presence or not of emergency plans or procedures. The problem is the practical application of this knowledge. So that's why the shift should be moved from the strategic level to the tactical level when we want to apply something. And that's why we use Industry 4.0 concept. In particular, you can see here the 9 pillars of the Industry 4.0 concept. And in this case, in our research project, we used 3 of them, in particular simulation, virtual reality environments, and augmented reality, and systems integration. And today, I would like to talk to you about serious games. I think most of you know, have dealt in the past with games. But we are not talking about traditional games whose purpose is just for entertainment. We are talking about serious games where people want to learn something by applying something touching with their hands, procedures, what should happen in case of a crisis, and so on. So the problem is that the main difference between a serious game and a traditional game is that simulation-based serious games have something in the back, have something underlying, mathematical models, physical models that used to recreate the reality as exactly, faithfully. So for example, think about a fire in a traditional game, in usual game. I don't know if you ever played into Metal Gear Solid or Tomb Raider. A fire, it's always there, just to say, okay, there is a fire, keep aware from that. In our cases, serious games intend to recreate a fire, for example, by using real computational fluid dynamics equations. Of course, the problem is that in real-time systems, training systems, like in this case, these quite complex equations cannot be applied directly because the resultant data and structures are quite huge. So we need some different approaches. And this is the concept, the main mathematical effort behind this kind of project. The ultimate goal is to reach the plateau of the learning curve as fast as possible. So we want to train people as fast as possible because they should go again on the workplace instead of staying there, being trained forever. So actually, sustainability is also a quite important element in this case, because if you think about the Deep Horizon oil rig in the Gulf of Mexico, several days were needed to solve this problem. So if well-trained people were in that case, maybe timely actions, timely decisions can be made instead of staying there, acting like a deer blinded by headlights, for example. So maybe in this case, it's more useful to adopt a cowboy theory, doing something instead of staying there and see what happens. That's why I would like to show you one of our research projects we have dealt with in the last months. Actually, this is a quite big project, a national interest project, where different research institutions were involved in too. And our focus was on the emergency procedures and game logic, because the emergency procedures are, the game logic is based on the emergency procedures. After that, we recreated ad hoc case studies, and in particular, an oil refinery, an oil storage plant in Middle Italy. And after that, we focused on recreating a fully immersive experiential experience, because only in this case, you can think to obtain the maximum learning outcome. This is just a very quick overview of what's behind our system. This is, for example, one of the models that, one example of how the fire dynamics should behave, and also how the game logic is based on emergency procedures. And in particular, all the standard phases according to the standards available from the Federal Emergency Management Agency. You can move during a disaster from the alarm phase to the reconnaissance, response, and then recovery. And you can see here that an industrial disaster is quite a complex situation where different people should also cooperate to achieve a common results to solve the situation, to solve the disaster. And in the middle, there is usually the emergency manager, probably also known as incident commander, that is the one who always should be paranoid with everything, should task the other people, coordinate everyone. And you can see here in the surroundings also the people you used to coordinate with. For example, people that used to deal with the internal environment, so evacuation team, the firefighters, and the first aid team, as well as people that used to deal with technical knowledge, so people with knowledge about systems, machinery, production lines that should be shut down in order to avoid additional problems. Also people that have some legal or normative knowledge, as well as people that used to cooperate with the external environment, so the employer itself. In this case, of course, as you can see, the emergency manager is not the employer, but is someone with particular skills, specific skills and competencies, as well as the telephone operator, the one in charge of taking care of calling external resources, and so on. And as you can see, actually, in a well-constructed, well-designed training solution, people should be able to play a certain role, one of the previous ones, and cooperate with all the others. Of course, we can set up training solutions where there are different people working together. It's like multiplayer training solutions. But in case just one of you would like to train, standalone, let me say, the other guys, the other people in this picture should behave according to a certain logic. That's why a huge modeling effort has been devoted to recreate a very quite complex human behavior model under stress conditions. And these models are based has been constructed as a combination of knowledge-based systems, agent-based modeling, and fuzzy logic, in order to recreate a little bit the unpredictability and randomness due to human errors. And what's needed to underline is that all the models, the parameters, the COA, the course of actions, have been validated also by people during different project meetings because, you know, verification, validation, and accreditation phase is quite crucial during a simulation study. And this is actually how the simulation is working. This is the home page where the training session facilitator, the one who is in charge of configuring the scenario, should set up. And as you can see, you can, for example, configure the plant by choosing coordinates, the terrain type, employees, visitors that are currently in the plant, or think about the scenario, for example, and of course, external resources, the fire station, so the tankers, something about local authorities and police authorities, the civil protection, and hospitals with helicopters or ambulances. And so if you think about the number of parameters that are only in this screenshot, the training session facilitator is actually empowered to set up an infinite number of training sessions. So after that, you can also choose how to create this disaster. So you want to configure, for example, the file seed, the cause of the disaster, for example, an explosion in a specific tank. After that, you can set up the meteorological condition because according to them, the fire dynamics is changing accordingly. And for example, also the personal clinical situation with triage code, black codes, red codes, and so on. After that, since the games should foster personalized learning, We would like to include also and we included also in this training solution, the possibility for the user to set up a difficulty level that from time to time during the simulation is changing and is adjusted according to the performance of the player itself, according to some calibration algorithms. And after setting up some additional parameters related to the team, the emergency manager, for example, has at its disposal, you can also select the possibility to enjoy the virtual environment. And now we are on the side of the trainees. The trainees are welcome to the disaster via storytelling approach. And this is me trying to explain the trainees what is going on. For example, there is a fire in this specific point on Earth. And the initial fire area is, for example, 10,000 square meters, so quite huge. And these are the systems, and lots of other information are provided to the trainees. So promoting this kind of storytelling, otherwise people are in the virtual environment without knowing nothing about. At the end, after a very quite large presentation about the environment, the trainees are said that you have to solve the disaster in a certain amount of time, in a time window. The time window is automatically computed by the system according to a database we have included also in the solution based on the disasters that have occurred in the last century. So if the training session facilitator is setting up a specific fire, a specific disaster, according to what happened in the past, we are giving the trainee a similar time window to solve the disaster. And this is the control panel of the emergency manager. So as you can see here, the emergency manager has a list of information about the disaster, what is going on, a real-time scenario map, two-dimensional one, some information about the dynamic evolution of events, as well as a decisional center, where the the trainee should try to understand if it should task someone to do something, he in person should do something in the virtual environment. And he or she can also task the team. For example, in this case, he can task the firefighters responsible to start a tour in the plant because maybe there is someone is missing and we should try to search for him or her. Since this is a simulation, at the end we have some very detailed performance measure about the emergency scenario. For example, if we were able to extinguish the fire, if we're able to hospitalize everyone in the plant, and so on. And all the solutions can be exported very easily to Excel, so you can also carry out some post-training assessment and analysis. But one of the major results we have accomplished with this project is that we want now to analyze which are the why it is important to foster cooperation in this kind of situations. And in this case, we used to descend head-mounted displays that are interoperating each other in the same virtual environment. So the emergency manager is asking verbally or by using some microphones to the emergency team member to do something, for example, again, to start a tour in the plant. And the other one should perform the task to understand if someone is missing, to help them by using real-world gestures. And I can give you just a very quick overview of how the system works. In this case, you can see now an immersed operator. On the screen, you can see what the operator is watching on the head-mounted display. And is going, for example, in this case, to launch the evacuation alarm. What you can see is actually the ad hoc recreated oil storage in the middle of Italy, close to Rome, actually. And he has to launch the evacuation plan and carry out all the operation the emergency manager has taught for you. As you can see, also, we spent a lot of time in recreating the real gesture. For example, if you need to close a valve, a pressurized valve, or to do something, to call someone, you have to carry out exactly the real-world gesture, because we deeply think that gestures are also needed to immerse even more per people in the virtual environment. So, which are the conclusions of our study? Actually, we are trying to add some additional parameters and monitoring devices in this big project. For example, heart rate variability project, in order to understand if people are deeply immersed in the virtual environment. And in this case, this is actually the first study where, to our knowledge, where technical procedure knowledge and level of immersion, as well as the generation pattern and magnitude of the real feeling of being immersed in a real world has been created and designed. And from a technological perspective, we used a system-of-system architecture, because as you can see, there are different systems interoperating in real time to each other. And the results actually have confirmed, the preliminary results, we are still at the beginning of analyzing our results, have confirmed that even non-professional rescuers, even non-professional managers, non-professional people that have never dealt with response training or response activities, emergency response activities, were able to solve a little bit the scenario after a repeated exposure to this system. Maybe 6 times, 7 times, they started to achieve this kind of results. But actually, the most important thing is that, as I was mentioning at the beginning, people should behave, should act very timely. Immediately, they have to speed up the process of decision making. They should understand which are also the consequences of their actions, and how to coordinate the whole team. So this is quite a very huge overview of the project and our research activities. I hope you enjoyed the presentation, and thank you.